Alright, so when you're doing kinematics problems, you're going to be using these three equations. Notice that all three of these equations have acceleration in them. What that means is you can solve for acceleration using any one of these equations. I'm going to show you how to do that algebraically, and then Mr. Collins is going to give you a quiz on it. Alright, I'm going to show you step by step how to solve for the acceleration in each of the three kinematics equations. Mr. Collins is going to give you a quiz on this, so watch closely and practice. And in no time, you will accelerate at this. Alright, so first equation. So I need to get acceleration by itself, so I'm going to subtract by v naught x on both sides. And my final step is to divide by t on both sides. And so I am dividing everything by t. And that's how you solve for acceleration using the first equation. Alright, second equation. I need to get a by itself, so I gotta get rid of these two terms first. So first thing, I'm gonna subtract x naught on both sides. Okay. Second step, I'm going to subtract this entire term, v naught xt, on both sides. And yes, you could have subtracted both of those terms, x naught and v naught xt, at the same time. I'm just going through this step by step. It's fine to do it either way. So, still in the process of isolating the acceleration. So I have a 1/2 here, so I can divide by 1/2 on both sides, which is the same thing as multiplying by 2 on both sides. So that's what I'm going to do. And I'm multiplying 2 to everything, so make sure you have those parentheses. And then finally, the only thing left is this t squared. I'm going to divide by t squared on both sides. And so I'm dividing the entire thing by t squared. And there I've solved for acceleration, and that's how you do it using the second equation. Bada bing, bada boom. That one was probably the most difficult one. I've got my last equation here. I'm going to solve for the acceleration. So first thing is to subtract v naught x squared on both sides. So I gotta get acceleration by itself. So I'm gonna do this all in one step. I'm going to divide by 2 and divide by x minus x naught at the same time. So I'm dividing the entire side by 2 and x minus x naught. And I'm dividing by 2 times x minus x naught because these are essentially multiplied to each other. If you want, you can break that down into 2 steps. And that is how you solve for acceleration. This is how you solve for acceleration using all three equations. And again, Mr. Collins is going to give you a quiz on this. So make sure you practice knowing how to solve for acceleration using every single one of these equations. Okay, and finally I'm going to show you how to do a units check when you're solving for acceleration. So instead of plugging in numbers into the variables, I'm going to plug in the units that these quantities are measured in. A units check is useful in that it tells you whether you solved the equation correctly. So when we plug in our units, we should get meters per second squared because we're solving for an acceleration. So for each variable, I'm going to plug in the units that quantity is measured in. Alright, so Vx, right? Vx is a speed. Speed is measured in meters per second. So meters per second. V naught x is also a speed, also measured in meters per second, and t time is measured in seconds. Okay, so if I subtract two numbers that have units of meters per second, so if I was subtracting 4 meters per second minus 2 meters per second, I'd get 2 meters per second. But here we just care about the units. I get meters per second on top and seconds on the bottom. To get rid of this gross multi-story fraction, it becomes meters per second squared, or meters per second is meters per second squared. That is what I want. I'm solving for an acceleration. and I ended up with my units being meters per second squared, which is what I expected. If you did not get meters per second squared, that would mean that you solved the equation incorrectly. Alright, from the second equation, we solved for acceleration, and we got this. So let's check if we solved it right by checking the units. The number 2 does not have any units, so not plugging in anything for that. X has units of meters. X naught also has units of meters. V naught x is a speed, so it is measured in meters per second. And t is time, that's measured in seconds, so multiplied by seconds. Okay, and on the bottom I have a t squared, which is time squared, so the units are seconds squared. Okay, let's simplify this a bit further. Okay, if I'm subtracting two values with the units of meters, I'm going to get a value with units of meters. Meters per second times seconds, these seconds are going to cancel out, and I'm left with meters. So subtract meters, and I've got seconds squared. And our final simplification here, if I have two values with meters, and I subtract them, then I'm going to get a value that has units of meters. The second squared is left, and so I got that my units are meters per second squared, which is what I expected because the units of acceleration are meters per second squared. This means that we solved the second equation correctly. Alright, and from the final equation we got this equation to solve for acceleration. So let's plug in our units and find out if we did it right. When we check our units, we're expecting to get meters per second squared. So Vx squared. Vx is a speed. Speed is measured in meters per second, but because it's squared, I have meters squared over seconds squared. So everything is squared in that meters per second. Minus another speed squared, so that's also measured in meters squared over seconds squared. And all of that is divided by 2. Does not have any units, so I can ignore it. X minus x naught, x is measured in meters, as well as x naught, also measured in meters, because they are positions. So I can deal with what's on the numerator separately, and I can deal with what's on the denominator separately. So I'm going to attack the numerator. If I'm subtracting two values that have the same units, or meters per second squared, I'm left with a value that is meters squared over seconds squared. If I'm subtracting two values with the same units of meters, I'm left with a value of meters. Okay? So I'm going to break this down, and so what I can do is this meters squared on top is going to stay on the top. The seconds squared can be written down here in the denominator. So in the denominator, I end up having seconds squared times meters. Okay? So this whole fraction is in my numerator, right? And so the bottom of this fraction, the seconds squared, can go to the bottom of the whole entire fraction. So I put it over here on the bottom, and now I can see that one of the meters is going to cancel out. And because I had meters squared on top and one canceled out, I'm left with just meters on top and seconds squared on the bottom, and that is what I was expecting. So this is how you do unit checks. I'm showing you this for acceleration. You're going to be quizzed on this, so make sure you know how to do it. But essentially, you can use this method of plugging in units to make sure that your equation is correct and you're ending up with the units that you want.